Hello friends, welcome back to Analog Communication Tutorials. Today we'll learn what is called Dsbsc modulation. Okay, so in the previous video you have seen the generation of AM and the demodulation of AM. Right, now here we'll see what is called Dsbsc. Okay, in the previous videos I have explained you the generation of AM and also the demodulation of AM. And we know that AM has certain characteristics and we need to know why we are going for Dsbsc. We have AM generation, right? But why we need to go? These all are the modulation techniques under AM only. These are all generation of AM waves. But in the previous videos, we have seen the a type of modulation where we need the more information from the message signal, not from the carrier signal. But here in the previous techniques, what we have done, what happened there is we have got carrier also at the output end. That means 33% of the message only transmitted, whereas 67% of the power is wasted. Okay, so keeping that in view, we have gone for another technique called Dsbsc technique. Okay, what is Dsbsc? Dsbsc is double sideband suppressed carrier technique. Okay, it is called double sideband suppressed carrier. The name itself says it suppresses the carrier from the output which we get. Okay, that means after modulation there won't be any carrier signal, only there will be a sidebands. Okay, as I already mentioned in the previous videos that most of the information after modulation lies in the sidebands, not in the carrier signal. Okay, so that is the reason why what we do is we eliminate the carrier so that only sidebands will be there, and thereby we get 100% utilization of the power. Okay, now how this DSBSC generally look like is S of t, I will mention the d, it is m of t into c of t. Okay, that means it is a product of message signal and carrier signal. Okay, now if you see, it will be am ac cos 2 pi sct cos 2 pi fmt. I have considered both of the signals to be the what cos signals. Okay, this is called single tone DSBSC modulation. When I am considering the message signal to be cos 2 pi fmt, I am only considering one signal, one type of frequency. Okay, this is called single tone DSBSC modulation. No, it's not like that. If you want, the message signal can be anything, not the sine wave. Message signal can be anything. So write it as m of t only. Then after what you do? Basic next step, you convert it into Fourier domain. Okay, when you convert into Fourier domain, what happens here? This is AC by 2. This is AC by 2. Then m of t is multiplied with cos 2 pi sct. What happens here? It is a del function. M of f minus fc plus m of f plus fc. These two will get. Okay, that means I have plotted the frequency spectrum. At f equal to fc, I have message. At f equal to minus fc, I have message. Okay. Now, if you see, there is no carrier here. Only the message signal. This is the upper sideband. This is the lower sideband. Okay. So that what happens here is 100% power is utilized. Power is utilized. I'm saying efficiency. Is that 100% power is utilized here, because carrier we did not get in the output. To remove the carrier we need again more power. So for that case we have removed the carrier signal. Now this video I just want to conclude the generation and also the demodulation of the Dsbsc technique. Okay, so that at a stage it will be completed. So it might take a few more minutes. Okay, just be patient, we'll complete it faster. Okay, so this is the basic idea of Dsbsc. Right, now we'll go back to the first technique of this Dsbsc called generation of Dsbsc techniques. First one is balanced modulator technique. Okay, balanced modulator technique.